Hello, I'm Bill Shepard with BDI, and I'm here to present to you bearing-related products training with materials provided by Rotorclip and Climax Metal Products Company. First, we're going to cover related bearing products. We're going to talk about retaining rings, shaft collars, rigid couplings, and keyless bushings. Retaining rings, they're used for bearing preload and retention, and a lot of times you can save money by not having machined edges where you can actually use a retaining ring in place of that. So let's talk about bearing preload and retention, what it is, why it's necessary, and how it works. So what it is, it's applying permanent thrust load to the bearing so that it's securely installed and has no axial clearance. The reason for doing this is the bearing preload process eliminates unwanted clearances, creates high stiffness, and reduces noise and vibration, which increases bearing and application life. How that's done, Rotorclip offers 4 different solutions to fasten preload bearings and eliminate axial clearance. We'll go into more detail of these, but the 4 types are true wave springs, bowed retaining rings, beveled retaining rings, and constant section snap rings. So the true wave springs, they have different series. There's ones with gap or overlapping ends, and you see the picture there on the left shows the overlapping ends, and the one that also has the gap. They're used in overhead assembly. It makes overhead assembly possible since the wave spring can lightly grip the inside of the bearing. It can be installed automatically via a tapered mandrel similar to the automatic installation of retaining rings, and it provides even load force with small tolerances due to even sinusoidal waves in the design spring. So true wave springs, in combination with constant section or spiral rings, as displayed in the image there, provides for bearing retention and preload solution. Wave spring spiral ring combination eliminates the need for a cover plate and fewer machine shoulders, saving the expense of machining costs. Here's a reference chart from the manufacturer's catalog showing the different size rings matched up to different size bearings. Another type is the bowed retaining rings. There's different types. There's BSA external and BHO internal. Look at the diagrams, you can kind of see how those work. We would use a tool to either crimp down and reduce the size of the BHO to go internal, or you would expand the BSH to go external around the shaft. Compensating for accumulated tolerance is what bowed retaining rings are designed to do on a shaft or in a housing. Once snapped into the groove, bowed rings exert a force or preload on the retained parts for the range as specified in the Rotorclip catalog. The resilient preload retention, and they're most effective in greater than 1-inch application sizes. In the diagram in the lower left, you kind of see the yellow is the actual snap ring itself and how that would actually fit into retain that bearing against the shoulder and keep that shaft positioned properly. A beveled retaining ring, there's different series. There is a VSH external and VHO internal. Again, the diagrams show you that one's internal, one's external. And then the lower picture shows in the green the beveled edge of how that would actually be used into that groove. These rings have a 15-degree angle on the outer edge, combined with a complementary groove angle to eliminate end play by wedging itself between the groove and the retained part. It's used for rigid bearing retention. It's very effective in application sizes 1 inch and larger. The next type is the constant section snap rings, and these are really designed for bearing retention. Different sizes, different series, but there's HBL, HBM, and HBH, light, medium, and heavy. They're internal metric constant section rings designed to retain SAE standard metric bearings and housing bore. In the diagram, if you look at that, on the lower left, you have 2 rings holding a bearing in position in that housing, left side and right side of the bearing. The second diagram shows on the left side, there's a shoulder that's positioning that bearing, limiting it from sliding to the left. Then the snap ring goes on the right side, positioning it so that bearing has no actual movement on the shaft or in the housing. Again, here's a reference chart for the different series, light, medium, and heavy, and what bearing sizes they would be used with. Constant section snap rings designed for bearing retention is the SB series. Again, external metric constant section ring. They're designed to retain SAE standard metric bearings on a shaft. Again, same type of diagram. 2 rings being used to retain a bearing on the left, and 1 snap ring being used in the diagram on the right, where the shoulder holds it in place on the left. This is SB reference chart out of a manufacturer's catalog, again showing you what size bearing number the snap ring would be used to work with. Again, it's more on constant section snap rings. There's the DIN standard 5417 external metric constant section ring, again designed to retain metric bearings on a shaft. And then the S&L series, same type of product, light duty ring designed for needle bearing applications on shafts. Here's a good display of all the different types and sizes of standard constant and tapered section retaining rings. Again, it's all different manufacturers. The material provided here is from Rotoclip, and they have a great breadth of product and range of coverage. Next, we're going to talk about shaft collars and the applications of shaft collars. So, quick overview. So, shaft collar, what does it do? The basic purpose is to position or locate a component on a shaft. It stops or limits the travel of a shaft in reciprocating applications. It's sold as a companion product to bearings, pulleys, sprockets, similar other products. It's used as a spacer between components, and it's used as a guide on a shaft. This diagram shows what shaft collars look like next to that pillow block bearing. Again, positioning that pillow block bearing on the shaft, not letting it move left or right. We'll talk more about the rigid coupling in the next section. So again, this is the components on the shaft, that gears on the shaft, and that shaft collar to the left of it actually keeps that gear from sliding or moving on that shaft left or right axially. So what types of shaft collars are available from Climax? Again, Climax is the one that provides the content. There's other manufacturers. Climax offers both domestic and import line of shaft collars. The most basic is the set screw collar. It's just basically a round ring with a threaded hole with a set screw on it that holds that onto the shaft. There's one-piece clamping collars, and you see that split on one side. Again, you have to put it on from the end of the shaft to slide in position. Then you clamp down that cap bolt. And then there's a two-piece clamping collar. This one has recessed screws, but you can actually take it apart and make two pieces, clamp it around the shaft in any position of the shaft without having to have it slide in from the end. And those are more functional when you have mounted equipment that you don't want to have to remove all the way from the end of the shaft. They also have custom-made to order shaft collars as well. So some set screw collar characteristics. The set screw is the most common, it's the most economical design. The collars hold the shaft via cut point set screw that impinges onto the shaft, which provides holding power of the collar. The design requires disassembly of shaft components when the collar needs to be replaced. Again, you have to take it all the way to the end of the shaft to remove it or cut it off. Set screw collars are manufactured from steel, stainless steel, aluminum, and sometimes acetyl copolymer. Different finishes include black oxide, zinc, and yellow zinc dichromate. The one-piece clamping collar characteristics has a single tangential screw. The one-piece design allows for additional holding power versus a set screw collar, with the added benefit that it does not mar the shaft. So there's no set screws going into the shaft itself. This design requires disassembly of shaft components when the collar needs to be replaced. Again, you got to slide all the way to the end of the shaft. One-piece clamping collars are manufactured from steel, stainless steel, and aluminum. Again, available finishes include black oxide, zinc, and yellow zinc dichromate. The two-piece clamping collar characteristics has two tangential screws. With two screws, this style provides more holding power than one-piece clamping collar. Set screws are placed equally on both sides of the collar. And the main advantage with the two-piece style is the ability to install the collar without any major disassembly of other components. So again, you don't have to take it all the way to the shaft. You can actually mount it right in place. Two-piece clamping collars are manufactured from steel, stainless steel, aluminum, and acetyl. The finishes include black oxide, zinc, and yellow zinc dichromate. Some different application uses. There's tons of them out there, but here's some examples. Would be really to locate different products, to guide products, use as an end stop. You can also be welded in place. So here's two pictures of examples of shaft collars on an ATV where it's positioning that seat rest. Another example where they have it on a medical halo for positioning that headset. So shaft collars have a lot of high volume applications that are out there: conveyors, exercise equipment. I won't go through all the detail, but paint mixers, hospital beds, ATVs, and go-karts. They're really used in almost every mechanical application in different plants. So in summary, what should you know about shaft collars? Really understand the difference between a set screw collar, one-piece clamping, and two-piece clamping collars. Understand the purpose of the shaft collar, again, positioning, retaining. And understand applications with shaft collars I use. There's just a myriad of those that are out there. And understand the reason to select Climax shaft collars. There's lots of different manufacturers that are out there, but again, Climax did provide the content for this training. Next, we'll talk about rigid couplings and the different applications. So rigid coupling, what does it do? So the basic purpose is to serve as a component for timing, joining, or aligning of shafts at lower speeds and torque, especially where zero backlash is desired. Applicable for aligned shafts only. They are the most basic coupling available, often the most cost-effective coupling option. They're very compact and economical. So in this example, imagine those are two separate shafts, and the rigid coupling on the right is connecting those two shafts. Again, they can be different diameters for shaft couplings. You can have one that's 1 inch, one that's 3/4 inch, and still make that connection. But you really have to make sure that they're aligned for this to work properly. Again, components of the shaft showing the picture there, the rigid coupling connecting two different shafts, holding them together. So what types of rigid couplings are available from Climax? They have both domestic and import line of rigid couplings. The most basic is the set screw coupling, pictured there. Again, uses set screws that would actually mar the shaft. The one-piece clamping coupling split on one side. It's got recessed and non-recessed screw head styles. It's available as a step bore clamping coupling, so you have bore sizes of different on each end. Two-piece clamping couplings, recessed and non-recessed screw head styles available, and it's available as step bore clamping coupling as well. Again, that allows you to kind of position that anywhere along the shaft. Remachinable couplings also have a recessed screw head style. There's also some that are custom made to order. We'll go into more details about each of these as we go along. So the set screw coupling characteristics, it's the most common and most economical shaft coupling design. It holds the shaft via cut point set screws that impinge on the shaft, which provides the holding power of the coupling. This design requires disassembly of shaft components when the coupling needs to be replaced. Set screw couplings are manufactured from steel, stainless steel, and aluminum with or without a keyway. Steel products include a black oxide finish, and it's also available with 4 set screws for extra holding power. The one-piece clamping coupling characteristics have 4 socket-head cap screws. One-piece design allows for additional holding power than a set screw coupling, and it does not mar the shaft. Design requires disassembly of shaft components when the coupling needs to be replaced. One-piece clamping couplings are manufactured from steel, stainless steel, aluminum, and with or without a keyway. Steel products include a black oxide finish. The two-piece clamping coupling has 8 socket-head cap screws. With 8 screws, this style provides greater holding power than a one-piece clamping coupling. The main advantage with the 2-style piece is the ability to install the coupling without any major disassembly to other components. Again, you can mount it anywhere along the shafts. Two-piece clamping couplings are manufactured from steel and stainless steel with or without a keyway. The steel products include a black oxide finish. Remachinable couplings. So this is one where you actually can rebore out the coupling to your desired shaft size on either end. It's a unique two-piece clamping coupling, has undersized ID that allows room to be rebore and key the ID without damaging the clamping screws. Its remachinable couplings allow for customer customization and limits downtime and resulting profits. Available in stock from steel and stainless steel, and the steel products include a black oxide finish. Application uses, joining aligned shafts, providing zero backlash, compact and economical, and can be welded in place. And there's an example of a rigid coupling in that picture shown there. So what are some high volume applications for rigid couplings? Again, conveyors, people movers, lots listed there, lawnmowers, automatic doors, remote control toys, food processing equipment. And we see these in a lot of different applications. Very, very quick and easy to make a change on this type of coupling. So rigid couplings. So, what should you know? Understand the difference between a set screw, a coupling, a one-piece clamping coupling, and a two-piece clamping coupling. I think the images help demonstrate that. Understand the purpose of a rigid coupling. Again, connecting 2 shafts with zero backlash. Understand applications where rigid couplings are used. There's plentiful applications out there. Understand reasons just like Climax rigid couplings. The next section, we're talking about keyless locking devices and their applications. So what is a keyless locking device? So a KLD, as it's referred to, creates a 360-degree clamping force on the shaft to position components. There are basically two types. There's internal locking assemblies, keyless locking assemblies. These KLDs reside between the shaft and the hub to create both internal and external connections. There's also external shrink discs, and these KLDs sit outside of the hub, compressing it down onto the shaft. I highly recommend going to Climax's YouTube page or any other manufacturer's YouTube page and watching demonstration videos of how these are installed. It makes it a lot more clear about how to use these and what applications they can be used for. So KLDs provide advantages over traditional shaft type connections. We have keys, keyways, and set screws, splines, shrinker press fits, QD taper lock bushings, hex nut keyless bushings. Those all have certain limitations that KLDs really kind of overcome. So keys, keyways, and set screws, they're inexpensive, but again, they're subject to wallowing out over time when subjected to reversing or start-stop motion. The erosion of keyways can cause backlash and fretting. In some cases, this fretting can lead to cold welding of the hub to the shaft, or even fracturing of the shaft itself. So the KLD advantage is because KLD does not require a keyway, these problems are not present when they replace keyways and set screws. Splines, so both spline, shaft, and drive elements must be machined, which is costly and time-consuming. Splines also have backlash and associated problems. Splines cannot be repaired in the field. So a KLD is simple and quick to replace a KLD because no machining is required. As far as shrink or press fits, these fits require close tolerances and expensive finished work. The applications for shrink fits, either heat or dry ice, are expensive, cumbersome, and potentially hazardous. Dismounting, reinstallation in the field is difficult and time-consuming. So the KLD advantage, they are quick, safe, and easy to install and disassemble, but no need for treatment. QD or taper lock bushings, again, keyways are still required. Wallowing occurs, which can eventually lead to fretting and backlash. These designs require either tapered bore in the component or a mating weld-on hub. They were not meant to transmit reverse bending loads. So the KLD advantage, without keyways or the need for modified bore in the component, KLDs are flexible for any design. Another example, hex nut keyless bushings. It's difficult to apply measured torque to a tightening nut. Hex nut keyless bushings are not self-locking. Dynamic loading can loosen the connection. So the KLD advantage, KLDs are self-locking and have a number of separate locking screws. So measuring torque during installation is simple. So the working principle of a keyless locking assembly. Again, tapered rings work like wedges to convert clamp loads into radial contact pressure, both internal and external. As the screws are tightened, the wedges come together to tighten onto the shaft as well as expand into the hub of the component. It also allows for almost infinite positioning as far as aligning, say, the teeth of a gear or a sprocket if it's a timing application. When the specified screw tightening torque is reached, the predetermined load capacity is achieved. So the working principle of a shrink disc, tapered rings work like wedges to convert locking screw clamps loads into the radial contact pressure. As the screws are tightened, the shrink disc provides a 360-degree locking force down on the component. Radial forces squeeze the hub, bridging and applying pressure onto the shaft. So you have both clamping onto the shaft and then external expansion into the hub to lock it in place. Assembly and disassembly. Mating components should be machined with a straight bore. Locking assemblies can be installed over a keyed shaft. Locking assemblies drop in with generous clearance fits and are typically installed with machine oil on mating components. Shrink discs demand tighter machining tolerances to limit diametral clearance and are typically installed with clean and dry shaft hub interface. By loosening the screws, all KLDs are easily disassembled, and all KLDs are shipped with written instructions on how to install them. So KLDs, what should you know? Understand the difference between an internal locking assembly and an external shrink disc. Again, I highly recommend watching the YouTube videos and how these are installed and used on different applications. Understand the advantages of KLDs over traditional shaft tip connections. Again, anything with a keyway has a risk of wallowing out, so KLDs don't have that issue. And understand the basic working principle of locking assemblies and shrink discs. Again, watching those YouTube videos is very helpful. Understand reasons to select Climax keyless locking devices. Again, there are lots of different manufacturers out there, and Climax was generous to provide all the content for this presentation. And with that, I want to thank you very much for your time and appreciate your attention to related bearing products today. Have a great day.